Hello everyone and welcome to Introduction to Remote Sensing using QGIS. In this video lesson we are going to learn how to search for, how to download and how to process some optical remote sense data. In particular we are going to be using Sentinel-2 dataset owned and operated by European Space Agency. So let's just briefly have a look at this dataset's infographics directly from ESA web pages. You can see that the constellation consists of 2 satellites with descent revisit, and most of the application ranges from application in agriculture, land use management, forestry management, and others. And that is because there is a whole bunch of quite a nice range of spectral bands separated by separate wavelength, obviously, and spatial resolution of the satellite. It's quite suitable for this kind of analysis, which is in a medium spatial resolution category. For most of the bands, it's 10-meter resolution, so that's pixel size is 10 by 10, and for some bands, it's 20 meter. As I said, we are going to be using QGIS for processing, not only for processing but also for downloading and viewing. Most of the functionality is already there within core tools included after you install the software, but some of the plugins are needed as well, so let's just have a look at those. So if you have not installed them, please go ahead and install them. First, for download, we are going to be using a semi-automatic classification plugin. Then for identifying area of interest, Quick Map Services provides a list of the base maps, so that's another plugin, quite usable. And Map Swipe tool, this is just for viewing and comparing different datasets. First, let's find our area of interest, and this is completely random. We just go into Quick Map Services and we'll pick up something that we are probably the most familiar with at this point of time, and that's a Google Road layer. If we zoom closer to where we are at, so we go into Canada, BC, so this is still Alberta. Let's just zoom in, for example, into Kootenay Mountain, so something like this. And we are gonna have a look what's available from ESA for Sentinel radar. So we go to SCP drop-down menu, and in the options we choose download products. If you activate that menu, another dialog box gonna appear, and the first tab within these dialogs, we don't have to really fill in any login data, as long as we have this option, use alternative search for Sentinel-2, no authentication required, activated. So if you have it switched off, just make sure that you have it switched on. And then within search, we have to search by the area. So we click on upper left corner in the coordinates, so longitude or latitude, so you can see that cursor is actually active there. And then you activate option set area in a map. So just single click on icon with a big plus, and then you can minimize this area dialog box, and then within map view of QGIS, cursor is going to change this cross, and you just click on upper left corner of your area of interest. After click, you return to the dialog box itself, and you can either repeat the lower right corner, or you can even start typing it. So let's say this lower corner is already right in here, so it would be -116,537 0, and this option for latitude is 49.0789. And if you minimize this option and start clicking on the map, you actually can see highlighted area of interest and your area. So this is the area that software is going to navigate through the list of available satellite, and it's going to be listed within this view once we activate the search. But before we do so, let's just change date, because we are interested in vegetation or late vegetation period, so let's say it's going to be from August 1st of 2021 to the same year, but we go up till September. So essentially 2 months, August, September 30th. 1st August, September 30th. And I want to see a little bit more results, so not only 25, so let's say 50. Now I click on find. It might take a little bit longer, so I'm gonna pause video and I'll activate myself with recording once we have some results. Once search is done, software is going to offer us a couple of information per each scene. It is able to identify that particular location. So one of the most obvious and probably one of the most important is cloud coverage. So obviously you have product name, an ID, and acquisition date. Obviously, it's also quite important. But what we are looking for is essentially cloud coverage with a minimum percentage rate. So if you look at Sentinel, let's say, well, this one from 23rd of September, and you click on it, it should preview with in a thumbnail, so you can actually see where the clouds are. And this says 15%, but I would actually estimate it a little bit higher than that. So it's not always very accurate. But obviously, this would be our choice. So this is the satellite acquired on 21st of September, and there is 0 cloud cover. So obviously for our analysis, this would be quite suitable candidate. So right now I'm going to initialize download of the satellite. It's important to make sure that we don't have to load bands into QGIS right away, so I can switch it off. I don't need pre-processing of the images. I just need pure download. Just make sure that you do not have this option switched off. So if this option only in preview, if preview in layers is switched off, everything would be downloaded. So right now I have these 50 results, each and every one would be downloaded. It takes some time and obviously takes a space, so we don't want to do that. So let's just go ahead and click only if preview in layers, and then we'll click on the run. It will ask for location on hard drive, and software is going to save it. So let's just do that, and again I'll pause myself and I'll wait until download is done. Once download is finished, you can check on your hard drive where dataset was downloaded, and you can have a look, you know, on that individual bands, and there's a band 1 up to band 12 along with the metadata. It's actually stored on the hard drive in separate files. If you double click on one of these JP2 files, it could even be reviewed in graphical software. So let's say if you have Photoshop or GIMP or any other viewer, you would be able to review it. But let's go back to QGIS and let's have a look at this at the same place. So this is my place where files were located or files were saved, and right now you can even, you know, right click on file itself in the browser menu and look at the layers properties, and you can see that these are actually georeference rasters with EPSG 32611, which is WGS 84 UTM zone 11 coordinate system, and it is 16-bit unsigned integer for data type, and right in here you will see pixel size. It's 10 by 10 meters. So we can just simply double click on file itself in the browser tab, and it's going to be brought to the map view so we can see it in the layers menu. So let's just bring a couple of these last rasters up: B2, B3, B4 and B8. And if you are interested to see what those particular raster contains, you can have a look at list of the spectral bands with central wavelength value for particular band, And you can also see resolution. So B2, B3 and B4 are blue, green and red bands. All of them are with a resolution of 10 meters. And also B8 is actually visible and near infrared, which is also within 10-meter resolution. That is spatial resolution on the ground, of course. Let's just make a couple of changes, couple of modifications that's going to make our photo work a little bit easier to do. So first, let's just rename names, these long and complicated names of individual channels, to something more straightforward. So let's just call this B2 channel. I'll date there, and I'll just blue for the band. So this is band B02 and it is in blue spectrum. So B03, just rename this to date green, and we can keep that B03 right there, so we still know what it is. Another rename. I'll keep that name just for us to know and to remember when it was acquired. And the last one, channel number 8, is actually short. No, it's visible and near infrared, right? So that would be and all right. Next thing, what I would do is just change coordinate system from WGS 84 to the native coordinate system of downloaded raster. So simple action, and that set project coordinate system from layer would change that coordinate system for entire map view for our project within QGIS. As a next step, let's create virtual rasters, and these rasters would combine 3 different spectrum, 3 different bandwidths. And in first example that we are going to create, that would be red, green and blue channels combined into one satellite. So when you look at those channels, just go to the extent. These are color coded in a gray scale, each and every one of them. Some of them, you know, you can see them better than others. And obviously we can enhance this view, but what we are going to do, we are going to take these individual channels and create one raster file combining all 3 channels there. So let's have a look at the combination, or at the tool that we are going to use. In the processing, we are going to call toolbox, and from toolbox we are searching for build virtual raster tool. Let's just initialize that. What we need to do, we need to input layers. So these would be blue, red, and I'm sorry, blue, green, and red channels. Resolution, we go with highest, and then everything needs to be placed into separate band. When we run it, we are going to store it just as a temporary file. We don't want to commit to the hard drive just yet. Run it. Data set has been created. We see logged in here that it was created within 0.15 seconds. Processing is done, so I can close this table and I can actually organize this a little bit higher. So these are data set right there. What we have to do in here is actually color coded it a little bit differently, and that color coding is being done by mixing channels. So we are gonna open another toolbox, or actually another panel, and that panel is called layer styling, and within layer styling from the data type we are not changing multi-band color. We go with multi-band color, but within combination of bands we have to change red band to the band number 3 and blue band is band number 1. So this is actually our color coded natural composite. So let's just rename this. Let's call it natural composite. And let's create some other variations, including another channels as well. So we go to building virtual rasters as well, or again, and in this case we are gonna choose channel 8, channel 4, and channel 3, and that's going to be combination for our false color composite or infrared composite. So let's go back and we go highest. We are placing each in separate channels, saving to the temporary file, run it, close, and we have it right in here. Let's just rename it, and this is going to be infrared. It's right there, and again we have to organize channel a little bit, so let's go to layer styling, and this is our results. So next step with processing would be using these individual channels and even a combination, maybe if we create some vegetation in indices, and that would create a classification itself. So maybe we can load some satellite base map data, and in this case let's go to web, and we are just gonna bring satellite from Bing. So let's just zoom on this area, and this is our natural color composite. So let's see how those two are fitting together. And when we are using swipe tool, you can actually compare base map from Bing Maps to our color composite that we have created, the natural color composite, right? Let's have a look at combination of infrared and right in here, infrared and Bing map underneath, or base map. And what I'm trying to show in here is essentially I can see that there's here is the area of the burn that occurred within 2021 period, and you can actually see that quite distinctly on a false color or a near infrared color composite. So that would be good combination of band to follow up with the classification. So that's right in here. And classification is going to be presented in the next module. Thank you for your attention, and hopefully see you shortly.